Yes, good evening students. Today we have the discussion of velocity time graph. One of the important area for the examination area, it is examination corner, velocity time graph. There will be one question on velocity time graph. The question may be like this: one, what are the uses of the velocity time graph, or simply it is known as a VT graph, or derivation of the equations. So this VT graph can be used to find the equations of the motion. Before this velocity time graph, just I revise the things. Today's discussion, velocity time graph, and simply it is known as VT graph. Okay, fine. Just within 5 minutes I revise the whole thing. The physical quantity, the quantity which can be measured is known as a physical quantity. Physical quantity can be divided into two categories. One is a scalar and another one is a vector. The physical quantity which has only the magnitude, that is called scalar, and the physical quantity which has both magnitude and direction, that is called vector. If the body is said to be at rest if it does not change its position with respect to surroundings and the time. For example, right now I am at rest. Or the particle is said to be in motion if it changes its position with respect to surroundings and the time. I am in a motion now because I am changing my position with respect to this surroundings as well as the time. Using this motion, the motion can be caused by a force. Without the force, there is no motion, because if the body is at rest, so to displace that body from one point to the another point, we have to apply the forces. So the branch which deals with the action of the forces on a body is known as a mechanics. In mechanics, again, there are two branches. One is a statics and another one is dynamics. Statics means it is a study of the forces when the body is at rest, and dynamics means when the body is in motion. In that we have one is a kinematics and another one is a kinetics. Then some important terms, one is a distance, displacement, velocity and the acceleration. This is the revision, because in the last 4 classes I had completed all these points. What is the difference between distance and displacement? Distance is the shortest distance. Distance is the actual path covered by the particle. Displacement, it is the shortest distance between the 2 points. Then if you go with the velocity, means if you take a discussion of the velocity, velocity is defined as rate of change of displacement. Rate of change of displacement means it is a displacement divided by time taken, that is known as a what? Velocity. The velocity, there are 4 types. What? Yes, uniform velocity, variable velocity, average velocity, instantaneous velocity. What is uniform velocity? If the particle describes equal displacements in equal intervals of time, then we call that one as uniform velocity. If the particle describes unequal displacements in equal intervals of time, then we call that one as a variable velocity. And the particle total displacement divided by total time, then we call that one as average velocity. And velocity of the particle at any instant, at any position, that is known as what? Instantaneous velocity. The instantaneous velocity, it is written as v is equal to, that is limit of delta s divided by delta t, as delta t tends to 0, and this is the differential language, and we write this one as ds divided by dt. So this is the definition of the what? Instantaneous velocity. The next one is what? Acceleration. What is the acceleration? Rate of change of velocity, that is called acceleration. Again, acceleration, there are four types. One is uniform acceleration, variable acceleration, average acceleration, and instantaneous acceleration. What is uniform acceleration? Acceleration is said to be uniform if there is equal change in the velocity in equal intervals of time. What is the variable acceleration? If there is an unequal change in the velocity in equal intervals of time. What is the average? Total change in the velocity divided by total time, that is called average. And the last one is instantaneous acceleration. Instantaneous acceleration means acceleration of the body at any instant, at any position, and that instantaneous acceleration, it is written as, it is a limit of delta v divided by delta t, as delta t tends to 0. Yes, then it is also known as dv divided by dt. This is the expression for the instantaneous acceleration. So this is about the velocity and acceleration. The next one is about the graph. So graph, if you take a graph, how many types are there? One is a position time graph, velocity time graph, and another one is acceleration time graph. What is a position time graph? Now, what is a position time graph? If the time is taken along the x-axis, okay, and a displacement is taken along the y-axis, then the resultant curve itself is known as a PT graph, or it is also known as a position time graph. Different positions of the particle are represented at different intervals of the time. So now what happens? We get a one curve. With the help of that curve, we can judge what is the nature of the motion. There are four types. So this is the four, I draw all the four types. This is the third one and this is the fourth one. So if you take this time versus the displacement, in all the cases the same, it is a displacement versus the time, and this is also displacement versus the time, this is also displacement versus the time. So here, with respect to the time, there is no change in the displacement, therefore we say the particle is at a rest. And here, initially it is at rest. With respect to the time, it is moving with the increasing velocity. So it is also increasing velocity, and this one is the decreasing velocity. So these are the four different cases. This much we discussed in the previous class. This is total revision. Now we start with the velocity time graph. What is this velocity time graph? Okay. The velocity time graph, as the name itself indicates, velocity time graph, here the two parameters are, one is velocity and another one is a time. If time is taken along the x-axis and velocity is taken along the y-axis, then the resultant curve itself is known as velocity time graph. How to draw the velocity time graph? At different intervals of time, we represent the different velocities. For example, here you write 10 seconds, 20 seconds, 30 seconds, 40 seconds, 50 seconds. Here I write say 10 meters per second, 20 meters per second, 30 meters per second, 40 meters per second, like that. So when it is a 10, after 10 seconds its speed is 10. After 20 the speed is how much? 23. When after the time means 30 seconds, the instantaneous is say 24. 40 seconds it is a 28. It means that at different intervals of time, if we draw the velocities, the resultant curve itself is known as a velocity time graph. So in velocity time graph, again we have the means different types. So this is the first one, velocity versus time. If velocity versus time. If you take a graph in this, if the nature of the curve is a straight line, if it is a straight line, what its indication? You only imagine with respect to time there is no change in the velocity with respect to time. So when the time is 10 seconds, here, time is 20 seconds, here, time is 30 seconds, the same velocity, time is 40 seconds, that there is no change in the velocity with respect to the time. If there is no change in the velocity with respect to the time, then there is no acceleration. Therefore, the particle is moving with the zero acceleration. It is moving with zero acceleration. It means that there is no change in the velocity. Take the second one. If I plot a graph like this, velocity versus the time, if the curve is like this, so when the time is 0, the velocity is 0. With respect to time, the velocity is increasing. Therefore, what is the nature? What is the nature of this? So here we can say it has a zero velocity, and what is this? Increasing acceleration. The acceleration is increasing. Initially the body is at rest. With respect to the time, the velocity is increasing. If velocity is increasing, we know if there is a change in the velocity, then automatically there will be acceleration. Therefore, the body has certain zero velocity, and after some time there is a increasing acceleration. The third one is the same. If you plot a graph of time versus displacement and observe here, then what is the nature? Observe these two, both of them are increasing, but here the velocity is 0, but here the velocity is not 0. It has a certain initial velocity, but with respect to the time there is a increase in the velocity. Suppose there is an increase in the velocity, then obviously acceleration. Therefore, here it has a certain initial velocity and increasing acceleration. Okay, increasing acceleration, or you can say positive acceleration, increases, velocity increases, or increasing velocity. Increasing velocity, hence acceleration also increases. Fourth one, if you take a graph like this, here this is the, initially it has a certain velocity, but with respect to time there is a decreasing. So with respect to time there is a decreasing velocity, velocity versus time. Therefore we say it is a decreasing acceleration. This one is increasing, this one is decreasing velocity, and hence the acceleration also decreases. So fifth one, this is the case where the particle is increasing acceleration. It has increasing acceleration, but increasing uniform acceleration. The difference between these two is, it is acceleration, but this one is uniform. And another one is, if you take the time versus velocity, and if the nature of the curve is like this, it is a decreasing, and like this or like this, it is a decreasing. One more, if the graph is time versus velocity, if the nature of the graph is like this, observe carefully. So it is a decreasing acceleration, and again here also it decreases. So this is different one. We call this one as when the object is dropped. So if you drop the one stone, because of that gravity, continuously its velocity increases. Velocity, remember, gravity remains the same, 9.8. But initially its velocity is 0, but with respect to the time the velocity increases. Therefore, this is the positive part and this is the negative part. If you throw the one body, first it moves upward direction, there the velocity decreases. Initially the velocity decreases. Further what happens? When it reaches one peak point, later it comes back. If I throw this pen, initially its velocity increases, finally it comes to rest. Suppose if I throw like this, finally it comes to rest, one point. Observe that peak point, one point, the velocity becomes 0. So upward journey and a downward journey. In an upward journey, velocity decreases, finally it comes to rest. And a downward journey, it is at rest and continuously its velocity increases. So these are the different types of the velocities. Means velocity time graph, we have the different natures. One is a zero acceleration. Here it is a zero velocity with the increasing acceleration. It has a certain initial velocity with the increasing acceleration and increasing velocity, decreasing acceleration, like that. The last one is, that is what about the motion under the gravity. This is what the nature. Now I take an important discussion concerned with the velocity time graph. That is, what are the uses of the VT graph? Significance, we call that one as a significance of the VT graph. So to explain the significance of the VT graph, before that, once again I explain this one. Velocity time graph andre enri. If you take the time along the x-axis and time velocity along the y-axis, the resultant curve is known as velocity time graph. Bere bere avadiyalli bere bere velocity irtೈತಿ. ಅಂದ್ರೆ 10 ಸೆಕೆಂಡ್ ಒಳಗೆ 10 ಮೀಟರ್ ಸ್ಪೀಡ್ ಆಗಿ ಹೊಂಟಿತ್ತು, 20 ಇದ್ದಾಗ 17, when it is a 30 it is a 23, when it is a 40 it is a 27. At a different time the velocity is different. So ಅದನ್ನೆಲ್ಲ ಮಾಡಿ ಪ್ಲಾಟ್ ಮಾಡಿದಪ್ಪ ಅಂದ್ರೆ ಗ್ರಾಫ್ ತೆಗೆದಿವಪ್ಪ ಅಂದ್ರೆ that is known as a velocity time graph. There are different nature, means if we plot a graph, how you will judge? Observe this, with passage of the time there is no change in the velocity. Time hanga ಹೆಚ್ಚಾಕೊಂತ ಹೊಂಟೈತಿ, but velocity ಒಂದೇ ಥರ ಉಳಿದೈತಿ. We call this one as a zero acceleration. The second one is, here the particle is at rest, ನಿಶ್ಚಲ ಸ್ಥಿತಿ ಒಳಗೈತಿ, but when the time means with the passage of the time the velocity increases, and here the particle has a certain initial velocity and with respect to the time velocity increases, hence we write that one as a increasing acceleration. This one is a decreasing acceleration, that is also uniform means that is also increasing acceleration. The last one is, okay, the next one is a decreasing acceleration. The last one is motion under the gravity. The discussion now, what are the uses of the VT graph? So this will be your 2 marks question in your examination. What are the uses of the VT graph? Okay, and 1 5 marks question, derive the equations using the VT graph. Today we will consider both of them. So that is the examination corner. This part is very important. And Monday you have the examination physics cyclic test. First cyclic test it is physics. We start with the PCMB. ಅದರ ಬಗ್ಗೆ ಒಂದು ಸ್ವಲ್ಪ ಹೇಳಿಬಿಡ್ತೇನೆ. So every Monday there will be examination PCMB. First Monday, every Monday. Okay, Monday 1 month. One month ಒಳಗೆ 4 weeks. First week, second week, third week, fourth week. First, second, third, fourth. PCMB 4 ಟೆಸ್ಟ್ ಇರ್ತಾವೆ. ನೆಕ್ಸ್ಟ್ ಡೇ ಮಂಡೇ ಆದ ಕೂಡಲೇ ನೆಕ್ಸ್ಟ್ ಡೇ ಟ್ಯೂಸ್ಡೇ ವಿ ಹ್ಯಾವ್ ದ ಮಾಕ್ ಟೆಸ್ಟ್ ಆಬ್ಜೆಕ್ಟಿವ್. objective test 20 marks. Every Monday there is a theory of 30 marks. So Monday ಇದನ್ನಿತ್ತಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ ನೆಕ್ಸ್ಟ್ ಡೇ ಟ್ಯೂಸ್ಡೇ ಆರ್ ವೆನ್ಸ್ಡೇ. ಮಂಡೇ ಇತ್ತಪ್ಪ ಅಂದ್ರೆ ಟ್ಯೂಸ್ಡೇನೇ ಇರ್ತೈತಿ ಯೂಶ್ವಲಿ ಆಬ್ಜೆಕ್ಟಿವ್. ನೆಕ್ಸ್ಟ್ ಡೇ ಅಂತ ಬರೋದು ಟ್ಯೂಸ್ಡೇ ಇರ್ಬೋದು, ವೆನ್ಸ್ಡೇ ಇರ್ಬೋದು, ಥರ್ಸ್ಡೇ ಇರ್ಬೋದು. ಆ ವೀಕ್ ಒಳಗೆ ಒಟ್ಟು ಒಂದು ನೆಕ್ಸ್ಟ್ ಡೇ ಹಿಡ್ಕೊಂಡು ಯಾವಾಗ ಬೇಕಾದ ಕೇಳ್ಬೋದು. ಯು ಶುಡ್ ಬಿ ಅಲರ್ಟ್. ಸೊ ದಿಸ್ ಮಂಡೇ ವಿ ಹ್ಯಾವ್ ದ ಪೇಪರ್ ಆನ್ ಫಸ್ಟ್ ಚಾಪ್ಟರ್. ಈ ಚಾಪ್ಟರ್ ಮುಗಿಲಿಕ್ಕೆ ಬಂತು. ಥರ್ಡ್ ಚಾಪ್ಟರ್ ಮೋಷನ್ ಅಲಾಂಗ್ ಎ ಸ್ಟ್ರೇಟ್ ಲೈನ್. ಅಪ್ ಟು ಸಾಟರ್ಡೆ ಮಟ 1ನೇ ಚಾಪ್ಟರ್ ಕಂಪ್ಲೀಟ್ ಆಗ್ತೈತಿ, ಮೋಷನ್ ಅಲಾಂಗ್ ಎ ಸ್ಟ್ರೇಟ್ ಲೈನ್. ಅದ್ರ ಮ್ಯಾಗ ನಿಮಗೆ ಟೆಸ್ಟ್ ತೊಗೊಳ್ತಿರ್ತೀವಿ. 30 ಮಾರ್ಕ್ಸಿನ ಪೇಪರ್ ಇರ್ತೈತಿ. ಮಂಗಳವಾರ ದಿನ ಮಾಕ್ ಟೆಸ್ಟ್ ಅಂತ ಇರ್ತೈತಿ. ಅಂದರೆ ನಿಮಗೆ ಕ್ವಶನ್ ಪೇಪರ್ ಬಂದುಬಿಡ್ತೈತಿ. ನಿಮ್ಮ ಆ್ಯಪ್ ಒಳಗೆ ಕ್ವಶನ್ ಪೇಪರ್ಸ್ ಬರ್ತಾವೆ. ಟೈಮ್ ಅಲಾಟ್ ಮಾಡ್ತೀವಿ ನಾವು. 10 ಗಂಟೆಗೆ ಪೇಪರ್ ಸ್ಟಾರ್ಟ್ ಅಂತ ಹೇಳಿದ್ರೆ 10 ಗಂಟೆ ಪೇಪರ್ ಡಿಸ್ಪ್ಲೇ ಆಗ್ತೈತಿ ನಿಮ್ಮ ಆ್ಯಪ್ ಒಳಗೆ. 11 ಗಂಟೆಗೆ ನೀವು ಬರೆದು ಸಬ್ಮಿಟ್ ಮಾಡಿಬಿಡ್ಬೇಕು. 11ರ ನಂತರ ಬಂದರೆ ಅದು ತೊಗೊಳ್ಳೋದಿಲ್ಲ. 11ರಿಂದ ಬರೋದು ಫೋಟೋ ಹೊಡೆದು ಅದರೊಳಗೆಲ್ಲ ಆಪ್ಷನ್ ಐತಿ, ನೀವೆಲ್ಲ ನೋಡಿರ್ಬೋದು ಆ್ಯಪ್ ಒಳಗೆ. ಫೋಟೋ ಹೊಡೆದ ಸೆಂಡ್ ಅಂದ್ಬಿಟ್ರೆ ಅದು ನಮ್ಮಲ್ಲಿ ಪೇಪರ್ ನಾವು ಕಲೆಕ್ಟ್ ಮಾಡ್ತೀವಿ, ಅದರದ್ದು ವ್ಯಾಲ್ಯೂಯೇಷನ್ ಮಾಡೋಕ್ಕೆ ಬರ್ತೈತಿ. ನೆಕ್ಸ್ಟ್ ಡೇ ಅಥವಾ ಅದರದ್ದು ನೆಕ್ಸ್ಟ್ ಡೇ ನೋಡಿಕೊಂಡು ಮಾಕ್ ಟೆಸ್ಟ್ ಅಂತ ಇರ್ತೈತಿ. ಅಲ್ಲೂ ಕ್ವಶನ್ ಪೇಪರ್ ಬರ್ತೈತಿ. ದೇರ್ ಯು ವಿಲ್ ಹ್ಯಾವ್ ಅ 20 ಅಬ್ಜೆಕ್ಟಿವ್ ಟೈಪ್ ಕ್ವಶನ್ಸ್ ಫಾರ್ CET ಲೆವೆಲ್. CET ಲೆವೆಲ್ಲಿಗೆ ಕ್ವಶನ್ಸ್ ಅಂದ್ರೆ ಆಬ್ಜೆಕ್ಟಿವ್ ಹೆಂಗೆ ಬರಿಬೇಕಂತೇಳಿ ಮಾಕ್ ಟೆಸ್ಟ್ ಒಳಗೆ ಆನ್ಲೈನ್ ಟೆಸ್ಟ್ ಅದು. ಸೊ 20 ಕ್ವಶನ್ಸ್ ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್ ಮಾರ್ಕ್ ಜಸ್ಟ್ ABCD ಸಬ್ಮಿಟ್ ಅಂತ ಹೇಳಿಬಿಟ್ರೆ ಅಂದ್ರೆ ಆಟೋಮೆಟಿಕಲಿ ನಿಮಗೆ ಸಬ್ಮಿಟ್ ಮಾಡಿದ ಮೇಲೆ ವಿದಿನ್ 1 minute ಯು ವಿಲ್ ಕಮ್ ಟು ನೋ ಹೌ ಮಚ್ ಮಾರ್ಕ್ಸ್ ಯು ಗಾಟ್ ಇಟ್ ಫಾರ್ ದ್ಯಾಟ್. ಅಂದ್ರೆ ನೀವು 20 ಕ್ವಶನ್ನು ಮಾರ್ಕ್ ಮಾಡಿ ಕಳಿಸಿದ್ರಿ, 14 ಕ್ವಶನ್ಸ್ ಕರೆಕ್ಟಾಗಿದ್ದು ಅಂದ್ರೆ 14 ನಿಮ್ಮ ಮಾರ್ಕ್ಸ್ ಬಿದ್ದಾವಂತ ರಿಪೋರ್ಟ್ ಮಾಡ್ತಿರ್ತೈತಿ. ಪ್ಲಸ್ ನೀವು ಯಾವ್ಯಾವ ತಪ್ಪಿರಿ ಅನ್ನೋದು ರೆಡ್ ಇಂಕ್ಲಿ ಇಂಡಿಕೇಟ್ ಮಾಡ್ತೈತಿ. ಆಮೇಲೆ ಕರೆಕ್ಟ್ ಆನ್ಸರ್ ಆಲ್ಸೋ. ಯಾವ ಕ್ವಶನ್ ತಪ್ಪಿರ್ತೀರಿ ಅದಕ್ಕೆ ಉತ್ತರನೂ ಕೊಟ್ಟಿರ್ತೀವಿ ನಾವು. ಯಾವುದು ತಪ್ಪಿರಿ ಅದಕ್ಕೆ ನಾವು ಹೊಳ್ಳಿ ಉತ್ತರ ಹೇಳ್ತೀವಿ, ಕರೆಕ್ಟ್ ಉತ್ತರ ಯಾವುದು ಅಂತೇಳಿ. ಇಷ್ಟೆಲ್ಲ ಮಾಡಿಕೊಂಡು ಹೋಗೋದು. ಇದೆಲ್ಲ ಏನಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ ಆನ್ಲೈನ್ ಟೆಸ್ಟ್. ದಿಸ್ ಈಸ್ ಆಲ್ಸೋ ಆನ್ಲೈನ್, ದಟ್ ಒನ್ ಈಸ್ ಆಲ್ಸೋ ಆನ್ಲೈನ್. ಇನಿಷಿಯಲ್ ಸ್ಟೇಜ್ ಒಳಗೆ ತೊಗೊಳ್ತೀವಿ. ರೆಗ್ಯುಲರ್ ಕ್ಲಾಸಸ್ ದ ಸೇಮ್ ಪ್ರೊಸೀಜರ್ ವಿಲ್ ಬಿ ದೇರ್. ಅದರಲ್ಲಿ ಎಕ್ಸಾಮಿನೇಷನ್ ನೀವು ಬರೀತಿರ್ತೀರಿ. ಬಟ್ ಬಿ ಕೇರ್ಫುಲ್, ಆಲ್ರೆಡಿ ವಿ ಹ್ಯಾವ್ ಸ್ಟಾರ್ಟೆಡ್ ದ ಸಿಲೆಬಸ್. ಇನ್ನು ಬ್ರಿಡ್ಜ್ ಕೋರ್ಸ್ ಅಂತ ಕುಂತೀರಿ, ಎಲ್ಲಾರ ಬ್ರಿಡ್ಜ್ ಕೋರ್ಸ್ ಮುಗಿದು ಭಾಳ ದಿನ ಆಯಿತು. ವಿ ಹ್ಯಾವ್ ಸ್ಟಾರ್ಟೆಡ್ ದ ಸಿಲೆಬಸ್. ಎಲ್ಲನೂ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಒಳಗೆ ಯಾವುದು ಚಾಪ್ಟರ್ ಸ್ಟಾರ್ಟ್ ಆಗೈತಿ, ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ಸ್. ಫಿಸಿಕ್ಸ್ ಒಳಗೆ ಮೋಷನ್ ಅಲಾಂಗ್ ಎ ಸ್ಟ್ರೇಟ್ ಲೈನ್. ಕೆಮಿಸ್ಟ್ರಿ ಆ್ಯಂಡ್ ಬಯಾಲಜಿ ಆ ಸರ್ ನಿಮಗೆ ಹೇಳಿರ್ತಾರೆ. ಎಲ್ಲ ಚಾಪ್ಟರ್ಸ್ಗಳು ಸ್ಟಾರ್ಟ್ ಆಗ್ಯಾವ. ದಿಸ್ ಮಂಡೇ ಫಿಸಿಕ್ಸ್, ನೆಕ್ಸ್ಟ್ ಮಂಡೇ ಕೆಮಿಸ್ಟ್ರಿ ಎಕ್ಸಾಮಿನೇಷನ್ ವಿಲ್ ಬಿ ದೇರ್. ಬೇಸ್ಡ್ ಆನ್ ಯುವರ್ ಮಾರ್ಕ್ಸ್ ಓನ್ಲಿ ವಿ ಡಿಸೈಡ್. ನೀವು ನಿಮ್ಮದು ಬ್ಯಾಚಸ್ ಅದೆಲ್ಲ ಅದಕ್ಕೆ ಆನ್ಲೈನ್ ಕ್ಲಾಸಸ್ ಇವನ್ನೆಲ್ಲ ಅಬ್ಸರ್ವೇಷನ್ ಮಾಡಿರಿ. ಒಬ್ಬರೇ ಅಬ್ಸರ್ವ್ ಮಾಡೋದಲ್ಲ, ಯು ಟು ರೈಟ್ ಡೌನ್. ನಿಮಗೆಲ್ಲರಿಗೂ ವಿ ಹ್ಯಾವ್ ಪ್ರೊವೈಡೆಡ್ ದ ಕೋರ್ಸ್ ಮಟೀರಿಯಲ್. ಬೇಕ್ ಇಟ್ ಈಸ್ ಅವರ್ ಮಟೀರಿಯಲ್ ವಿ ಹ್ಯಾವ್ ಪ್ರೊವೈಡೆಡ್. ನೋಟ್ಸ್ ಬರೆಸೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ನೋಟ್ಸನ್ನು ನಾವು ಪ್ರಿಂಟ್ ಮಾಡಿ ಕೊಟ್ಟಿರ್ತೀವಿ. ವಿ ಕಾಲ್ ದಟ್ ಆಸ್ ಸ್ಟಡಿ ಮಟೀರಿಯಲ್. ಮೀನ್ ವೈಲ್ ವಿ ಹ್ಯಾವ್ ಗಿವನ್ ದ CET books also. You have all the materials, classes. Your job is observe the online classes, read the concerned notes given in the study material. You practice it, and every Monday you have to write the examination. This is what we are doing right now. Most probably your college will be started in the month of October 1st, 21st. They have given a government has given a permission to visit the school campus. We call few students, means we make a group and we call you to clear the doubts and all. Definitely we will do all these things. But remember, this Monday we have the paper. ಈ ಪೇಪರ್ ಒಳಗೆ ವೆಲಾಸಿಟಿ ಟೈಮ್ ಗ್ರಾಫ್ ಮ್ಯಾಗ ಡೆಫಿನೆಟ್ಲಿ ಒಂದು ಕ್ವಶನನ್ನು ನಾವು ಕೇಳ್ತೀವಿ. ಅದಕ್ಕೆ ಈ ಪಾರ್ಟನ್ನು ಒಂದು ಸ್ವಲ್ಪ ಸರಿಯಾಗಿ ಎಲ್ಲರೂ ಅಬ್ಸರ್ವೇಷನ್ ಮಾಡಿ. As I have told, there are two important questions on velocity time graph. One is, what are the uses of VT graph? The second one is derive the equations of the motion. The first one is what are the uses? First one is to find velocity and acceleration. To find the velocity and acceleration. Second one, area under the curve represents displacement. Third, to find nature of the motion. Fourth, to derive equations of motion. These are the 4 points. Remember, what are the uses? One is to find the velocity and acceleration at any time, at any instant. Second one is area under the curve represents the displacement of the particle. Third one is to find the nature of the motion. Fourth one is to derive the equations of the motion. Now I take one by one. To find the velocity and acceleration, I plot a graph of one VT graph. From that we will come to know. See, this is the graph 10 seconds, 20 seconds, 30 seconds, 40, 50 minutes, or you can write in terms of minutes. Okay, this is time. Here I take velocities 10 meter, 20 meter, 30 meter, 40 meters, meter per second. Suppose the graph is like this. To find the velocity and acceleration at any instant, if you want the velocity exactly at 30, so at means if you want the velocity of that body after 30 seconds, 30 seconds means here you take a one vertical line. Okay, from this take another horizontal line. So here nearly about it is say 24. It means that 24 meter per second. So when means after 30 minutes the velocity becomes how much? 24 meters per second. Similarly, acceleration. For the acceleration we have to take two different velocities. Okay, two different velocities. Then we write that one as a tangent of the tangent. So tan theta, we define a tan theta. Tan theta means opposite side divided by adjacent side, opposite side divided by opposite side is velocity, adjacent side is time. Velocity divided by time, velocity divided by time, it is nothing but what? Acceleration. So first one is to find the velocity and acceleration. Over. The second one is area under the curve represents the displacement of the particle. Area under the curve represents the displacement of the particle means, observe this one, this is what? Time, this is the velocity, this is the curve. So this is the initial and this is the final. I draw this, I complete this. This is what the area, you can write like this. Okay, you take this. This is the area under the curve. This area represented by the boxes represents the what? This represents the what? Displacement. The third one is to find the nature of the motion. In the beginning only I explained nature of the motion means by observing the graph one can explain whether the body is at rest or with the increasing acceleration or not. The last one is to derive the equations of the motion. Now I am going to explain how the velocity time graph can be used to derive the equations of the motion. So these are the 4 important points, and in your examination they ask only what are the uses, and this is what the explanation. No need of explaining the things, no need of giving the explanation, just you have to represent these, just you have to write these 4 points to get the marks. ಇನ್ನೊಮ್ಮೆ ಯೂಸಸ್ ಏನಂತ ಕೇಳ್ತಾರೆ, ಒಂದು ಟು ಫೈಂಡ್ ದ ವೆಲಾಸಿಟಿ ಆ್ಯಂಡ್ ಎಕ್ಸಲರೇಷನ್. ಅಂದ್ರೆ ವೆಲಾಸಿಟಿ ಟೈಮ್ ಗ್ರಾಫ್ ಗೊತ್ತಿತ್ತಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ ನೀವು ಏನು ಮಾಡ್ಬೋದು, ಅದರದ್ದು ವೆಲಾಸಿಟಿ ಎಷ್ಟೈತಿ, ಎಕ್ಸಲರೇಷನ್ ಎಷ್ಟೈತಿ ಕಂಡುಹಿಡಿಬೋದು. ಈಗ ನಾನು ಇಲ್ಲೊಂದು ಗ್ರಾಫ್ ತೆಗೆದೀನಿ, ಆ್ಯಂಡ್ ಅಲಾಂಗ್ ದ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಏನು ಮಾಡೀವಿ, ಟೈಮ್ ಮೆನ್ಷನ್ ಮಾಡೀವಿ, ಇಟ್ ಈಸ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಮಿನಿಟ್ಸ್. ಅಲಾಂಗ್ ದ ವೈ ಆಕ್ಸಿಸ್ ಏನು ಮೆನ್ಷನ್ ಮಾಡೀವಿ, velocities mentioned ಮಾಡಿವಿ, and this is the graph. Suppose if you want a velocity after 30 minutes, 30 ನಿಮಿಷದಾಗ 30 ನಿಮಿಷದ ನಂತರ ಎಷ್ಟು ವೆಲಾಸಿಟಿ ಇತ್ತು ಅಂತ ಯಾರು ಕೇಳಿದ್ರೆ 30 ಮ್ಯಾಗ ಮಾರ್ಕ್ ಮಾಡಿ ಒಂದು ವರ್ಟಿಕಲ್ ಲೈನ್ ತೆಗಿತೀವಿ, ಅದು ಎಲ್ಲಿ ಕಟ್ ಮಾಡ್ತೈತಲ್ಲ ಹಾರಿಜಾಂಟಲಿ ಒಂದು ಕಡೆ ತೊಗೊಂಡು ಬಂದರೆ ಇಟ್ ಈಸ್ 24. ಅಂದ್ರೆ ಅರ್ಥ 30 ಮಿನಿಟ್ಸ್ ಆದಮೇಲೆ ಅದರ ಸ್ಪೀಡ್ ಎಷ್ಟಾಗಿತ್ತು, 24. ಈ ಥರ ನಾವು ವೆಲಾಸಿಟಿ ಕಂಡುಹಿಡಿಬೋದು. ಎಕ್ಸಲರೇಷನ್ ಕಂಡುಹಿಡಿಬೇಕಾಗಿದ್ರೆ ಏನು ಮಾಡಬೇಕು, to find the acceleration, if you take one vertical and horizontal, ಹಿಂಗೆ ನೋಡಿದ್ರೆ ಇದು ವೆಲಾಸಿಟಿ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಿರ್ತೈತಿ, ಆಮೇಲೆ ಇಲ್ಲಿ ಟೈಮ್ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಿರ್ತೈತಿ. ಆ್ಯಂಡ್ ವಿ ಹ್ಯಾವ್ ಒನ್ ಡಿಸ್ಕಷನ್ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಸ್ಲೋಪ್ ಅಂತ ಬರ್ತೈತಿ, ಮುಂದ್ಗಡೆ ನೋಡೋಣ ಅದನ್ನು, ಥೀಟಾ. ಸೊ ದೆನ್ ವಿ ಡಿಫೈನ್ ಟ್ಯಾನ್ ಥೀಟಾ, ಅಪೋಸಿಟ್ ಸೈಡ್ ಡಿವೈಡೆಡ್ ಬೈ adjacent side. Opposite side is v, adjacent side is t. Velocity by time is nothing but acceleration, therefore 1. So ಏನಾಯಿತು, 1 to find velocity and acceleration. Second one is area under the curve represents the displacement. vt ಗ್ರಾಫ್ ಒಳಗೆ ನಾವೇನು ತೆಗಿತೀವಿ, ಆ ಗ್ರಾಫ್ ಒಳಗಡೆ ಬಂಧಿತವಾಗಿರ್ತಕ್ಕಂಥ ಏರಿಯಾ ಐತಲ್ಲ, ಇಟ್ ಆಲ್ವೇಸ್ ರಿಪ್ರೆಸೆಂಟ್ಸ್ ದ ವಾಟ್, ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಆಫ್ ದ ಪಾರ್ಟಿಕಲ್. ಅಂದರೆ ಇದು ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಮಟ್ಟ ಐತಿ, ನಾನು ಏರಿಯಾ ಮಾಡೀನಿ, ಈ ಏರಿಯಾ ಏನು ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೈತಪ್ಪ ಅಂದ್ರೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಆಫ್ ದ ಪಾರ್ಟಿಕಲ್. ಥರ್ಡ್ ಒನ್ ಈಸ್ ಟು ಫೈಂಡ್ ದ ನೇಚರ್ ಆಫ್ ದ ಮೋಷನ್. ನೇಚರ್ ಆಫ್ ದ ಮೋಷನ್ ಗ್ರಾಫ್ ನೋಡಿದ ಕೂಡಲೇ ರೆಸ್ಟ್ ಒಳಗೈತು, ಇನ್ಕ್ರೀಸಿಂಗ್ ವೆಲಾಸಿಟಿ, ಡಿಕ್ರೀಸಿಂಗ್ ವೆಲಾಸಿಟಿ, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ನೇಚರ್ ಆಫ್ ದ ಮೋಷನ್. ಈಗಾಗಲೇ ನಾವು ಅದನ್ನು 5-6 ಗ್ರಾಫ್ ತೆಗೆದು ತೋರಿಸಿದೆ. ದ ಲಾಸ್ಟ್ ಒನ್ ಈಸ್ ಟು ಡಿರೈವ್ ದ ಇಕ್ವೇಷನ್ಸ್ ಆಫ್ ದ ಮೋಷನ್. It is our next discussion, how the velocity time graph can be used to find the equations of the motion. There are 3 equations: v is equal to u plus ct, s is equal to ut plus half it square, v square minus u square is equal to 2s. We derive these equations using the vt graph. Right, now we start with the discussion, that is velocity time graph can be used to find the equations of the motion, to derive the equations. Before that, one more graph we have. What is that? Acceleration time graph. Acceleration time graph, again it is a simple one. Instead of velocity, if you take the acceleration here, then it becomes acceleration time graph. Acceleration time graph means acceleration is taken along the y-axis and time is taken along the x-axis, and the graph is known as acceleration time graph. And in acceleration time graph, again different curves. Acceleration time graph, I write it if you want that one, acceleration time graph, I repeat. But before that, I revise these 4 points because for examination point of view it is a very important. Therefore I put a double star, double bar. Double star means it's an indication of it is a 2 marks question. Double bar, very important. If I put a dots, then it indicates that it is a compulsory question for the examination. So this is a what code word we use. Instead of writing IMP, this is a IMP, this is a VIMP or VIMP. So if you may write like this also. If you write like this, it indicates that impossible, very very impossible. This question is impossible. Like it is a coding. If you use a one code word, it gives so many informations. It indicates the marks, it indicates examination point of view, very important. for 2 marks, and this indicates compulsory questions. So what are the uses? One, to find the velocity and acceleration at any instant, at any time. The second one is area under the curve represents the displacement of the particle. The third one is to find the nature of the motion. The fourth one is to derive the equations of the motion. These are all uses of the velocity time graph. Now the discussion, position time graph. Position time graph, there again two axes. One is x-axis and another one is a y-axis. X-axis always represents time. Okay. So now the discussion is position time graph. And here instead of V, we write it as P. Okay. This is position time graph, and it is not a position time graph, it is an acceleration time graph. Already we have completed position time graph, we want an acceleration time graph. What is this? Acceleration time graph. In acceleration time graph, the same, time is taken along the x-axis and acceleration, it is taken along the y-axis. The resultant curve itself is known as a what? Acceleration time graph. Here at the different intervals of the time, we represent the accelerations. Okay. So what happens here? Different intervals of time, we represent the acceleration, we get this nature. There are four different cases I can draw. Okay. Yes. So here time versus acceleration, time versus acceleration, time versus acceleration, time versus acceleration. Okay. So if the graph is like this, if the nature of the graph is straight, zero acceleration means what? Uniform velocity. Here it is a increasing acceleration, here it is a decreasing acceleration, here it is what? Variable acceleration. Variable acceleration means increase, it may increase or it may decrease, that is called variable acceleration. So this is about the what? Acceleration time graph. For our examination, they ask velocity time graph. This acceleration time graph is nothing but it is a replica of velocity time graph. Instead of velocity, here we take acceleration. Okay. So this is about the what? Acceleration time graph. The next discussion is about deriving the equations of the motion. How the velocity time graph can be used to derive the equations of the motion, that is your next discussion. For that, okay, important question it is called kinematics. We know to derive the equations of the motion, velocity time graph can be used. How the velocity time graph helps us to find the equations of the motion. Today I take one, tomorrow two more questions. One is, heading is to find equations of motion using VT graph. Okay, this is your heading. The first one is V is equal to U plus AT. We have to prove this. Consider VT graph. This is the VT graph. This is the x-axis and y-axis. The particle is at A. With respect to the time, the velocity increases, the particle is at B. Okay. Here this is at B. This is initial velocity and this is final velocity. I write it. Initial velocity. What is this initial velocity? Arambhika vega. It is denoted by the letter U. Right. And this is final velocity. And this is denoted by the letter V, and this is V. This is what you call this one as a C, and this is equal to how much? V. Right. The initial velocity is U. The final velocity, this is V, this is U, and this is V. Now I draw one perpendicular. I call this one as a D. If it is U, obviously it is also how much? U. And this is V and this is U, means this is V. From that I remove VU. This becomes how much? V minus U. And OC represents what? Time. Therefore, this also represents what? Time. And this is the angle theta. So, this is what the graph. It's a very simple one. ಒಂದು ವಸ್ತು ಆರಂಭಿಕವಾಗಿ ಇಲ್ಲಿತ್ತು, ಅದರ ಆರಂಭಿಕ ವೇಗ u ಐತಿ. ಸ್ವಲ್ಪ ಸಮಯದ ನಂತರ ಅದರ ಅಂತಿಮ ವೇಗ v ಆಗೈತಿ. ಅಂದರೆ ಇದು ಆರಂಭಿಕ ಬಿಂದು, ಇದು ಅಂತ್ಯ ಬಿಂದು. This one is the initial position and this is the final. Initial velocity and the final velocity. ಸೊ ಇಲ್ಲಿಂದ ನಾವು ಒಂದು ಡ್ರಾ ಮಾಡೀವಿ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್. ಅಂದರೆ ಇದು ವಿ ಐತಿ, ಇದು ಯು, ಇಲ್ಲೊಂದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್, ಇದು ಯು ಐತಿ ಅಂದರೆ ಇದು ಸಹಿತ ಏನಿರ್ತೈತಿ ಯು. ಓಕೆ, ಇಫ್ ಇಟ್ ಈಸ್ ಯು, ಆಬ್ವಿಯಸ್ಲಿ ಇಟ್ ಈಸ್ ಆಲ್ಸೋ ಯು. ಎಷ್ಟು ಉಳಿತು? ಇಷ್ಟರೊಳಗೆ ವಿ ಒಳಗೆ ಯು ಕಳೆದ್ರೆ ದಿಸ್ ಬಿಕಮ್ಸ್ ಹೌ ಮಚ್? ವಿ ಮೈನಸ್ ಆಫ್ ಯು. ದಿಸ್ ಈಸ್ ದ ಟೈಮ್ ಟಿ, ದಿಸ್ ಈಸ್ ಆಲ್ಸೋ ದ ಟೈಮ್ ಟಿ, ಬಿಕಾಸ್ ಎರಡು ಈಕ್ವಲ್ ಅದಾವ. ದೆನ್ ದಿಸ್ ಈಸ್ ಥೀಟಾ. ಫೈನ್. ನೌ ವಾಟ್ ಈಸ್ ದ ಡೆಫಿನೇಷನ್ ಆಫ್ ದ ಆಕ್ಸಲರೇಷನ್? Acceleration is nothing but slope. Slope is nothing but tan theta. Remember this one. Slope is nothing but tan theta. Slope in physics, we take the help of that word, that is tan theta. Tan theta is nothing but it is a slope. Slope is also known as a derivative. It has its own importance. Already you are familiar with the word that is a tan theta. Tan theta is nothing but it is opposite side divided by adjacent side. Opposite side is how much? BD. Adjacent side is how much? AD. Acceleration, it is denoted by the letter A. What is the value of BD? The value of BD is equal to V minus of U. What is the value of AD? AD value is equal to T. In the denominator, there will be 1 by cross multiplication. So if you cross multiply, V minus of U is equal to AT, or V is equal to U plus AT. This is your 5 marks question. In your examination, they may ask this one. Very simple, but you should write a systematic explanation for this presentation. In your examination, if there is a question, prove that V is equal to U plus AT using the VT graph, your answer should be like this. Consider the VT graph in which time is taken along the x-axis and velocity is taken along the y-axis. A body has a certain initial velocity u, it is at A. After time t seconds, it reaches the point B with a final velocity v. Draw BC perpendicular to the x-axis and AD perpendicular to BC. By geometry, this becomes v minus of u and it is a time. We know that acceleration is nothing but slope of the curve. Slope is nothing but tan theta. The slope is tan theta in this triangle. Tan theta opposite side divided by adjacent side. BD divided by AD. So A is equal to, we know the value of BD, it is a v minus of u and AD is equal to d. By cross multiplication, v minus u is equal to AT or v is equal to u plus AT. By observing this one, some of you may feel it is a mathematics. No, it is not a mathematics, it is a physics. For that purpose only, in the beginning only I said, if you are good in mathematics, definitely you feel physics simple. And if you are good in physics, definitely mathematics will support you to score more. Mathematics is a secret key. Mathematics is the key for all these things. Higher physics, higher chemistry, wherever you go, mathematics plays very important role. It is all stolen from your trigonometry. This is nothing but it is a part of trigonometry, but it looks like a mathematics, but it is a physics. Almost all the derivations are like this only. Okay, so this is about the what v is equal to u plus at. ಇನ್ನೊಂದು ಸಲ ಇದು ಒಂದು ಆರಂಭಿಕ ವೆಲಾಸಿಟಿ u ಐತಿ, ಅಂತಿಮ v ಐತಿ, ಒಂದು ಸ್ಲೋಪ್ ತೆಗೆದುಬಿಟ್ರೆ ಎಕ್ಸಲರೇಷನ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಸ್ಲೋಪ್ ಟ್ಯಾನ್ ಥೀಟಾ, ಅಭಿಮುಖ ಬಾಹು ಡಿವೈಡೆಡ್ ಬೈ ಅಭಿಮುಖ ಬಾಹು, ಆಮೇಲೆ ಇದಕ್ಕೆ ಏನಂತ ಕರಿತೀವಿ ನಾವು ಪಾರ್ಶ್ವಬಾಹು, ಅಪೋಸಿಟ್ ಸೈಡ್ ಡಿವೈಡೆಡ್ ಬೈ ಅಡ್ಜಸೆಂಟ್ ಸೈಡ್. ಅವತ್ರ ಬೆಲೆಗಳನ್ನು ತುಂಬಿದ್ವಿ, ಓರೆ ಗುಣಾಕಾರ ಮಾಡಿದ್ರೆ ವಿ ಈಸ್ ಈಕ್ವಲ್ ಟು ಯು ಪ್ಲಸ್ ಟಿ. ನೋಡಲಿಕ್ಕೆ ಗಣಿತ ಅಂತ ಕಾಣಿಸ್ತೈತಿ, ಬಟ್ ಇದು ಫಿಸಿಕ್ಸ್ ಒಳಗೆ ಜಾಸ್ತಿ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ನ ನಿಮಗೆ ಮುಂದ್ಗಡೆ ಬರೋದು. ಬಟ್ ಯು ಆರ್ ಗುಡ್ ಇನ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್, ಡೋಂಟ್ ವರಿ ಅಬೌಟ್ ದ್ಯಾಟ್. ನಾಳೆ ಕ್ಲಾಸ್ ಒಳಗೆ ಏನು ಮಾಡೋಣ ಅಂದ್ರೆ ಇನ್ನೆರಡು ಮೂರು ಇಕ್ವೇಷನ್ಸ್ ಅದಾವೆ. ಒನ್ ಈಸ್ ಎಸ್ ಈಕ್ವಲ್ ಟು ಯು ಟಿ ಪ್ಲಸ್ ಹಾಫ್ ಇ ಟಿ ಸ್ಕ್ವೇರ್, ಸೆಕೆಂಡ್ ಒನ್ ಈಸ್ ವಿ ಸ್ಕ್ವೇರ್ ಮೈನಸ್ ಯು ಸ್ಕ್ವೇರ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 2as. One more is distance covered by the particle in the nth second. Nth second means Sn is equal to, that is u plus a by 2 to n minus of 1. That is a distance covered by the particle in the nth second. Okay, ಇವನ್ನೆಲ್ಲ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಒಳಗೆ ಮಾಡ್ತೀವಿ. ಮಂಡೇ ಎಕ್ಸಾಮಿನೇಷನ್ ಇರೋದ್ರಿಂದ ಇಲ್ಲಿ ಮಟ್ಟ ಆಗಿರ್ತಕ್ಕಂಥ ಎಲ್ಲ ಆನ್ಲೈನ್ ವೀಡಿಯೋಸ್ಗಳನ್ನು ನೋಡಬೇಕು. ಬ್ರಿಡ್ಜ್ ಕೋರ್ಸ್ ಅಲ್ಲ, ಡೇ 1 ಡೇ 2 ಅಂತ ಮೋಷನ್ ಅಲಾಂಗ್ ಎ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಅಂತ ಸ್ಟಾರ್ಟ್ ಆಗಿರ್ತೈತಿ. ಅವನ್ನೆಲ್ಲ ನೋಡಿಕೊಂಡು ನಿಮ್ಮ ಆ್ಯಪ್ ಒಳಗೆ ನೋಡಿರಿ. ಆಮೇಲೆ ಏನಾದರೂ ಡೌಟ್ಸ್ ಇದ್ದಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ ಡೈರೆಕ್ಟ್ಲಿ ಯು ಕ್ಯಾನ್ ಮೆಸೇಜ್ ಮೀ. ಅಂದ್ರೆ ಅದ್ರ ಆ್ಯಪ್ ಒಳಗೆ ಒಂದು ಆಪ್ಷನ್ ಐತೆ, ಅದು ನೀವು ನಿಮ್ಮ ಡೌಟ್ಸ್ಗಳನ್ನು ಕ್ಲಿಯರ್ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ ಯು ಕ್ಯಾನ್ ಸೆಂಡ್ ದ ಫೋಟೋ ಆರ್ ಯು ಕ್ಯಾನ್ ಸೆಂಡ್ ದ ಮೇಲ್ ಟು ಅಸ್, ಕ್ಯಾನ್ ಸೆಂಡ್ ದ ಮೆಸೇಜ್ ಟು ದ್ಯಾಟ್ ಯೂಸಿಂಗ್. ಅದನ್ನು ನೋಡಿಕೊಂಡು ವಿ ವಿಲ್ ಆನ್ಸರ್ ಫಾರ್ ದ್ಯಾಟ್. ಅದರ್ವೈಸ್ ವಿ ವಿಲ್ ಹ್ಯಾವ್ ದ ಇಂಟ್ರಾಕ್ಷನ್ ವಿತ್ ಯು. ದೆನ್ ಪೇಪರು ಮಂಡೇ ವಿ ವಿಲ್ ಅನೌನ್ಸ್. ನಾವು ನಿಮಗೊಂದು ನೋಟಿಸ್ ಕಳಿಸ್ತೀವಿ, ಟೆಸ್ಟ್ ಟೈಮ್ ಅಂತೇಳಿ 10 ಗಂಟೆಗೆ ಅನ್ಕೊಳ್ಳೇನ 10 ಗಂಟೆಗೆ ಆ್ಯಪ್ ಒಳಗೆ ಕ್ವಶನ್ ಪೇಪರ್ ಡಿಸ್ಪ್ಲೇ ಆಯ್ತಪ್ಪ ಅಂದ್ರೆ ದೆನ್ ಟೈಮ್ ಅಲಾಟ್ಮೆಂಟ್ ವಿಲ್ ಬಿ 1 hour. ಇನ್ 1 hour ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್, ಆಮೇಲೆ ಸೆಂಡ್ ಅನ್ಬೇಕು. 11 o'clock ನಮ್ಗೆ ರೀಚ್ ಯಾರ್ಯಾರು ಆಗಿರ್ತವೆ ನೀವು ಪೇಪರ್ ಅಟೆಂಡ್ ಮಾಡಿರಿ ಅಂದಾಗ. ಲೇಟರ್ ಆಮೇಲೆ ಕಳಿಸಿದ್ದು ತೊಗೊಳ್ಳೋದಿರೋದಿಲ್ಲ, ಅದು ಆಪ್ಷನ್ ಇಲ್ಲ ಆ ಥರ. ಅದು ಮುಗಿದ ಮೇಲೆ ನಾವು ವ್ಯಾಲ್ಯೂಯೇಷನ್ ಮಾಡ್ತಿರ್ತೀವಿ. ಮಂಗಳವಾರ ದಿನ ಇದೇ ಟಾಪಿಕ್ ಮೇಲೆ ಆಬ್ಜೆಕ್ಟಿವ್ ಫಿಸಿಕ್ಸ್ ಅಂತ ತೆಗಿತೀವಿ. ಅಂದರೆ ಆಬ್ಜೆಕ್ಟಿವ್ ಕ್ವಶನ್ಸ್ ಯಾವ ಥರ ಬರ್ತಾವೆ ಅಂತೇಳಿ ಮಾಕ್ ಟೆಸ್ಟ್ ಅಂತ ಕರೀತಾರೆ ಅದಕ್ಕೆ. ಅದು 20 ಆನ್ಲೈನ್ ಆಗಿರ್ತೈತಿ. ಅದು ಆನ್ಲೈನ್ 10 ಗಂಟೆಗೆ ಸ್ಟಾರ್ಟ್ ಆಯ್ತಪ್ಪ ಅಂದ್ರೆ 10:30 ಕ್ಲೋಸ್ ಆಗಿಬಿಡ್ತೈತಿ. ಆಟೋಮೆಟಿಕ್ಲಿ ಸಬ್ಮಿಟ್ ಅಂದ್ಕೂಡಲೇ ನಿಮಗೆ ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಬಂದಾವ, ಎಷ್ಟು ತಪ್ಪಿರಿ ಅನ್ನೋದು ನಿಮಗೆ ಇದನ್ನೆಲ್ಲ. ದಿಸ್ ಇಸ್ ದ ಸೆಕೆಂಡ್ ಟೈಮ್ ಐ ಆಮ್ ರಿಪೀಟಿಂಗ್. ಆಲ್ರೆಡಿ ಈಗೊಮ್ಮೆ ಹೇಳೀನಿ, ಮತ್ತೊಂದು ಸಲ ಯಾಕೆ ಹೇಳತ್ತೀನಪ್ಪ ಅಂದ್ರೆ ಮಂಡೇ ದರ್ ಈಸ್ ಅ ಟೆಸ್ಟ್. ಈ ಪಾರ್ಟ್ ಭಾಳಷ್ಟು ಇಂಪಾರ್ಟೆಂಟ್, ಪೇಪರಿಗೆ ಕೇಳೋ ಚಾನ್ಸಸ್ ಜಾಸ್ತಿ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.